Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a problem on the maximum charge that can be given to capacitors. The question is as follows. A capacitor of capacitance C1 is equal to 2 mu F can withstand a maximum voltage V1 is equal to 6000 volts, and another capacitor of capacitance C2 is equal to 4 mu F can withstand a maximum voltage V2 is equal to 4000 volts. Now, the two capacitors are connected in series as shown in the figure. Find the maximum voltage that can be applied across the series combination. Before proceeding to solve the problem, let us recall the related concepts. When a potential difference V is applied across a capacitor of capacitance C, the charge on the capacitor is given by Q is equal to CV. When the applied voltage is gradually increased, the charge on the capacitor also increases accordingly. A given capacitor can hold a certain maximum amount of charge Qm, hence we can apply a certain maximum voltage Vm across the given capacitor such that Qm is equal to C into Vm. When two capacitors are connected in series, the charge on the two capacitors are equal. The voltage across each capacitor is inversely proportional to its capacitance, and the voltage across the combination is equal to the sum of the voltages across the two capacitors. The voltage applied across the combination should be such that the voltage across each capacitor is less than or equal to its maximum voltage. Now, we are in a position to solve the problem in the question using these concepts. It is given in the question that C1 is equal to 2 mu F and C2 is equal to 4 mu F. Also, maximum voltages across C1 and C2 are V1 is equal to 6000 volts and V2 is equal to 4000 volts. Therefore, maximum charge on C1 and C2 are Q1 is equal to C1 V1, which is equal to 2 mu F into 6000 volts, which is equal to 12,000 mu C, and Q2 is equal to C2 V2, which is equal to 4 mu F into 4000 volts, which is equal to 16,000 mu C. Therefore, the voltage applied across the series combination should be such that the voltages across C1 and C2 should be less than or equal to their maximum values, which implies Q should be the smaller of Q1 and Q2. Therefore, Q is equal to 12,000 mu C. Therefore, under these conditions, voltage across C1 is V1 is equal to Q by C1, which is equal to 12,000 mu C divided by 2 mu F, which is equal to 6000 volts, and voltage across C2 is V2 is equal to Q by C2, which is equal to 12,000 mu C divided by 4 mu F, which is equal to 3000 volts. Therefore, maximum voltage applied across the series combination is V is equal to V1 plus V2, which is equal to 6000 plus 3000, which is equal to 9000 volts, which is the answer to the question.